So which topic we had started? Uh, Anyone remembers the topic that was started? Good evening, everyone. Am I audible?
Yes, sir.
Yes, sir. Good evening.
Okay. So which topic did we start? We had started with a new chapter, I think.
Good evening, sir.
Yeah, good evening. So which chapter we had started with?
Sir, we didn't started with any chapter, sir.
Yeah, we started with a new chapter, I think. So that's what I want to know. Which chapter did we start?
Sir, and this month, 21st, September 21st is my science exam.
Oh, September 21st. All right.
Yes, sir.
Okay. Give me 1 minute, please.
Yes,
And
sir.
look up. So you won't help me with what topic was done?
Like, sir, with the assertion and reasoning, sir. Like that.
Which one?
Assertion and reasoning type questions, sir. I am not able to answer those kind of questions.
Assertion and reason question. From which topic?
Sir, from physics and chemistry.
Okay. Just let me recall what topic we did in the last class. I have actually forgotten the topic that we did.
Combustion and flame. So, good evening, sir.
Combustion and flames.
Combustion and flame. Yeah. So we completed the question answer from combustion and flame also.
Yes, sir. We discussed about combustion.
Okay. I sent you the complete exercise, right?
Good evening, sir. Yes, sir. Yes, sir.
Yes. Yes. So in the group, I had sent you the complete exercise for the review. Okay. What is the next chapter that we shall start? Can you check the index
Coal
and
and
tell me?
petroleum.
Coal and petroleum we have done. Is there motion chapter?
So can we start sound?
No, not sound. Sound will be almost at the end. Okay, is there
Sir,
any chapter?
can you revise chemical effects of electric current?
Yeah.
Sir, my portion, sir.
Hmm?
Effects of electric current will be good, sir.
Okay, let's start with chemical effects of electric current.
Sir, I have also some doubts related to it.
Okay, okay.
My portion I have is, sir, what all lessons you are saying, sir, those only they're starting and they are keeping those.
Pardon?
Sir, you have started a fiction and the same chapters only they are starting.
Okay, let's revise. Electric chemical effects of electric current. Chemical effects of electric current. See. So in this chapter, basically we are looking for conductors and insulators of electric current. So what all things we need here for the electric current, we had seen some testers. So we will quickly revise everything. A cell is generally represented by this symbol, a positive terminal and a negative terminal.
Sir, are you presenting?
Just one minute. I forgot to present. Let me present it. Alright. So see chemical effects of electric current. We'll see an electric circuit. We'll see some testers. Okay. So an electric circuit, it consists of a cell, a switch, which is generally represented like this. This is an open switch, and this one is a closed switch. Then we see some instruments like bulb, represented like this, and some other instruments also. So over here, we had seen conductors. So what are conductors?
Sir, that the materials that allow current to pass through them easily.
Okay. So how can we test that whether a substance is a conductor or not? How can we do that? Yes. How can we check whether a substance is a conductor or not?
Sir, we should pass the electricity through it, sir. Like we should try it. If it does not conduct electricity, it is not a conductor, sir. So
So
hence
how can we test it?
like it we can connect with it a wire, sir.
So
Sir,
how?
we can make a circuit, and in the between we can remove the piece, and then we can keep whatever substance you want, sir. So
Yes.
if we keep a metal, then the current will pass, sir.
Yes. So basically, if you want to test it, generally we test the presence of electric current with the help of a bulb. Okay. So we use a bulb over here. We construct a simple circuit consisting of a bulb, a cell, a switch. So, so we construct a circuit consisting of a bulb, and here we connect the substance which is to be tested. So we connect the substance that is to be tested over here. Then we complete the circuit by making a switch, a cell. Okay. So if you turn on the switch and the bulb doesn't glow, then we say that it is a poor conductor. And if it glows, then we say that it is a good conductor, right? Yes, Gautam?
Yes, sir.
Okay. So Krishna, what do you think over here? Can we say this circuit, is this circuit efficient? Can we rely on this circuit?
Yes, sir.
So this
Sir, if the
circuit,
dot is there, it is in on position.
if you turn this,
So for switch, if you have the dot in the middle, so that is on.
yeah, the switch is on. See, the switch is on.
Okay, sir.
I say, okay, Pranav, can I rely on this circuit for testing the conductivity?
Yes, sir. But if we have a good conductor of electricity, it depends on the substance which we take.
See, this circuit is not reliable. Why the
Sir,
circuit is? Why
sir,
the circuit is?
something,
Yeah.
sir, because sometimes the parts may also be damaged.
Sometimes.
The parts may also be damaged, like the bulb or the cell.
No. The problem is not there. The problem is here with the bulb. Okay. See, the problem is there with the bulb. The problem is that bulb works on the heating effect of electric current. Okay. It works on heating effect. So see, how does it work? If some current passes through the bulb, the filament of the bulb gets heated up. And when the temperature of the filament reaches a certain high value, then only it starts glowing. So if there is small amount of current passing through this conductor, maybe the bulb will not glow. And even if it is a conductor, we will assume it to be an insulator.
Sir, so what if we keep an LED bulb?
Yeah.
What if we keep an LED bulb?
Yes. So instead of using LED bulb, we use LED lights. So instead of using this bulb, we use LED lights and the circuit becomes reliable. So Gagana, what is the full form of LED?
Light emitting diode.
Yeah. LED, it is a light emitting diode and it can glow even if small amount of current passes through it. Yes, Lasya?
Sir, when we use, what happens to told, sir? The
When we
LED
use,
bulb. When we use the LED bulb, what happens?
okay, see here we are not using the LED bulb first. First we are using this filament bulb. Okay.
Yes, sir.
So in the filament bulb works on the principle of heating effect of electric current.
Yes, sir.
So in this filament bulb, if small amount of current passes, then it will not glow.
Yes, sir.
So when this bulb will not glow, so that means if for small currents it won't glow and hence it will give us a wrong idea. We will get a wrong concept. Okay. To remove that,
Yes.
we use LED bulbs or LED lights. So LED lights or light emitting diodes, they consist of these two terminals, one of the terminal being a longer one and the other one being shorter one, and they look something like this. LED lights. So even if a small amount of current passes through the LED light, they will start glowing. So LED lights, they are a better tester. Got it? Instead of using this
Yes, sir.
filament bulb, we use LED lights.
Yes,
Okay.
sir.
Now there is another one of. Is there any other way of making a tester? Is there any other concept that we can use for making a tester?
So magnetic.
Yeah. So another tester. This is your first kind of tester. LED lights, it is a second kind of tester. We can use some more testers like for the third one. So third one we can use magnetic effect of electric current as tester. So see, magnetic effect of electric current. So see what happens when electric current is passed through a wire, then it behaves as a magnet. Right? When electric current is passed through a wire, it behaves as a magnet. So we utilize this effect for testing it. Okay. For testing the presence of electric current. So let us see what we do. Suppose we are testing a substance. So for testing a substance, we construct the circuit as I told you. In the same way, we'll construct the circuit. Our circuit will look like something like this. You can have a bulb or anything. You can have the substance to be tested. A switch, cell. Here you can have your bulb. However, the bulb is not used as a tester. Here you have the substance which you are testing. Okay. I want to test whether the current is passing through this wire or not. So for this thing, I take the help of a magnetic compass. So let us see how does a magnetic compass look like. Okay, see, this is how a magnetic compass look like. There is a small magnet on the needle. So the needle of the magnetic compass, it has a small magnet on it. So if it is brought near another magnet, generally it always point in the north-south direction. So if this magnetic compass needle is brought near the wire, so let's take it and add it to the wire. So if I bring this magnetic compass needle near this wire, and if the current flows through it, if the current is still flowing through this wire, so we will observe that the compass needle starts showing deflection. So the compass needle will show deflections when current passes through it. So we have made another kind of tester by using a magnetic compass. So instead, to make it more reliable, we try it some other way. Instead of to make it more reliable, we don't use it like this. See, we reconstruct the circuit here. And instead of placing it near the compass, we wind a wire near this compass. We wind this compass with wires and we complete the circuit like this. So here we place the substance that is to be tested. Then you can connect your switch, cell, and so on. So this completes the circuit. Now, whenever the current will flow through the wire, this compass needle will start showing the deflections. And if there is no current passing through it, the compass needle will not show any deflection. Got it?
Sir, is it compulsory that beside the switch only should be the battery or the cell?
No, you can keep it anywhere. The switch you can keep anywhere.
And the battery?
Yeah, you can keep it anywhere.
Okay, sir.
Sir, I also created one tester, sir.
Yeah?
I also created one tester in my home, sir.
Okay, you have created one.
Yes, sir. I
Yes.
made a circuit and wrapped it in a paper tube, sir.
Okay, that's good. That's good then. So now next thing is that in this chapter we won't be checking the solid substances. Here we'll be checking the conductivity of liquids. Here in this chapter we are more interested in liquids. Can liquids also conduct electricity? So can liquids also conduct electricity? Yes, is it possible for the liquids to conduct electricity?
Yes, sir.
Sir, yes, sir.
Hydroelectricity.
Hydroelectricity. Yeah, I'm not talking of generating electricity. Okay, I'm talking of conducting electricity.
Sir, salt water is a great conductor of electricity.
Yes.
Sir,
See,
lime water.
we'll think of these different solutions. Like we'll think of lime water.
Sir, liquids can conduct electricity.
We'll
Because
think of
sometimes,
tap water.
sir, because sometimes when rainfall happens, then we get shocks. Sir.
Glucose solution. You will
Sir,
have a
vinegar.
salt solution. And vinegar you can test. You can test for the conductivity of pure water, which we call as distilled water. Conductivity of distilled water.
Sir, distilled water is
Sir,
like
distilled
free of
water.
ions, right?
Yeah,
Free of salt ions.
yeah, a distilled water is water which does not contain any salt ions.
So, like it cannot conduct electricity.
Yeah, distilled water cannot conduct electricity. It is one of the properties of it. Anything else? Okay, so just let's check it whether they can conduct electricity or not. Okay, so what about lime water? Will it be a good conductor or not?
Yes, sir.
Yes, sir.
Okay, so lime water is a good conductor. What about tap water? Yeah, what about tap water?
Yes.
Yes, sir.
It can, sir.
Yes.
Yes.
Tap water is also a good conductor, so it's yes. What about glucose solution?
Sir, we can.
Yes, sir.
Yes or
Yes, sir.
no? Glucose water is not a good conductor. Glucose solution is not a good conductor. So it's not. What about the salt solution?
Yes, sir.
Yes, sir.
Yes,
Good.
sir.
It's a very good, sir.
So
It's a very good conductor. Yes.
salt solution is
Yes.
yes, it is a good conductor. Vinegar,
Yes, sir.
yes.
As
What about distilled
No,
water?
sir. No,
no,
What about distilled water?
no, sir.
No.
no, sir. No, sir.
Distilled water is not a good conductor.
Sir, then why glucose solution is not, sir?
There is a glucose content sugar.
Yes, pardon.
So, like, why is glucose and distilled water are not a good conductors?
Yes.
Sir, like glucose solution, why it is not a good conductor? The distilled water has no ions,
Uh,
but the
glucose does not form ions. Okay, it dissolves in water by forming hydrogen bonds with water, but it does not form ions.
yes, sir.
So therefore, glucose solution is not a good conductor. Okay, the method of solubility is different from glucose than salt. Okay, students. So we have these substances, these liquids. We have lime water, tap water, glucose solution, salt solution, vinegar, distilled water. Okay, in the same way, we can test different other substances also. Okay. So now see, we'll just check your chapter. Just I'll check your chapter here. So we just saw these testers, the LED bulbs. We just saw the tester we use at home. We just saw the tester made up of magnetic compass. Here we have some of the, okay, what do you think about the vegetable oil, milk and honey?
Both are they can they cannot.
Okay,
Detector, whereas milk and honey is not.
okay, anyways, you can test them. Okay, you can create a circuit and test them, which we are not going to do right now.
Sir,
So when, yeah,
which liquids are more acidic in nature, those are the good conductors of the electricity.
see, there should be the presence of ions. Some ions should be present in the solution, and if the ions are present in the solution, then the solution will be conducting. Simply, if it contains some salts, if it contains some acid, if it contains some base, so then it will be soluble. Then it will conduct. Otherwise, it will not conduct.
Okay.
Okay. So now here, see here a circuit has been shown to you passing current through water. Passing current through water. How do we pass current through water? You have a battery. Then two rods have been dipped inside the battery, inside water. These rods are called as electrodes. So there are two rods which are dipped in water, which we call as electrodes. Then these electrodes are connected to the two terminals of the battery with the help of wires. So with the help of wires, they have been connected to the battery. Okay. So when the electric current passes, see how the electric current passes from here. The current moves from the positive terminal of the battery. It passes like this. It passes to this positive electrode. Now, inside the solution, there is no passage for the movement of charges from the positive electrode to the negative electrode. So, only thing that can help is the solution. So, if the solution, that is water, is conducting, the charges will flow from the positive end to the negative end, and hence the current will travel from negative again from this terminal towards the negative terminal of the battery. Therefore, we will observe that the circuit is complete. So circuit will be complete only if the solution is conducting. If the solution is non-conducting, the circuit will not be complete. Got it? Okay, students. So we'll continue with from here in our next class. From here, we'll continue in the next class. That is, we'll start from here. Okay, carbon rods dipped in potato. You can check this one. A potato. A cutout piece of potato has been taken up, and we are using a magnetic compass as a tester. Electric current is passed through it. So here, towards the positive end of the wire, which is dipped in potato, we observe some change of color. Okay, so this change of color indicates that there is some reaction which is occurring at that end. It means that we can bring about some changes in the chemical by using electric current. Okay, so we'll continue our discussion from this point in our next class. Okay, okay, bye all of you. See you again in next class.
Sir,
Yes.
once go back to the NCRT book.
Which one?
NCRT book, sir.
I didn't get what you want to say.
Like once go to the NCRT page, sir.
Yeah, it's here only. Just let me share. Okay, there.
Sir, in this British chemist is there, no, sir, William Nichols.
Yeah.
He said that he immersed two electrodes, sir. Like in water and the current was passed, bubbles of oxygen and hydrogen were produced. Sir.
Yeah.
Oxygen bubbles form on the electrode on the positive and hydrogen on the negative Y, sir.
Okay, so this we'll discuss because see, water forms the ions as H plus and O minus. Okay, so those ions which are formed, H plus combines with electrons to give hydrogen gas, and oxygen from water, it liberates oxygen gas. Okay, the details we'll see in our next class. Okay, I'll explain this in the next class also. Okay.
Understood.